All right, for this lesson, we're going to be using the Pythagorean theorem and finding missing side measures in a right triangle. And some of these segments that you see won't have a right triangle drawn on them, or they won't be attached to a right triangle. So, for instance, if I go from the city hall, to the gas station here, city hall to the gas station, you'll notice that that's just one segment. But if I wanted to find the distance from City Hall to the gas station, I could draw some extra segments to make a right triangle there. But we'll talk about that in a minute. All right, let's go ahead and let's take a look at what we're getting into. Look at the recall. It says you've learned to find the distance or length of a line segment by drawing a square on the segment, finding the area, and taking the square root of the area. So I want you to take a look at this part right here. This is what I'm talking about. So look at the line segment in purple. So what I did is I drew a square on that line segment that's in purple, on this one right here, and calculate the area. I'm just saying that the area is 36. So we're gonna let it. I just made up a number. We're just saying the area of that square is 36. And again, I just made that up just to try to explain what I'm talking about. I could have put 64 in there. All right, so I'm saying the area of the square is 36. So the side length is the square root of 36, which is 6. So then again, that goes back to this. What did I do? I drew a square on the segment. The segment was the purple line. And then I found the area. Well, the area was 36 square units. Then I took the square root of the area, and it gave me the side length, which was 6. But instead of going through that like we did in the previous lessons, and like we did in just that example to the right, today we're going to use the Pythagorean theorem with right triangles. And the Pythagorean theorem says that a squared plus b squared equals to c squared. All that means is that the area of the two squares on the legs added together equal to the area of the square that's drawn on the hypotenuse. And let's talk about legs and hypotenuse one more time. A and B are called your legs. They make the right angle. We've already discussed this, but this is just recall. C is the hypotenuse, and it's always the longest side, the slanted side, and it's always opposite the right angle. Okay, let me put those in a different color. I'm going to highlight them. C is the hypotenuse. It's the longest side, the slanted side, and always opposite the right angle. All right, let's go down. All right, so it says for exercises 8 through 11, and notice I have 8, 9, 10, and 11 here. All right, so for exercises 8 through 11, use the map of Euclid. This map is called the map of Euclid, this coordinate plane. It says find the flying distance and blocks between the two landmarks without using a ruler. So no ruler. What we want to do is use the Pythagorean theorem to find the flying distance. And the reason why we're saying flying distance is because, let me see if I can get rid of this. I don't know. It's just on there. Suppose I wanted to go, and this is just hypothetically speaking, suppose I wanted to go from the stadium to the city hall. Now, keep in mind, this is a map of a town. So each of these little black lines, like here, and that run horizontally and vertically, those are your roads. So now if I were walking or driving, then I could just stay on these roads here. I could go, down, I could go south, and then I could go east to get from the stadium to the city hall. But if I want to go directly from the stadium to the city hall, I can't just run through this area right here, because this area is not a road. Okay, so like if I'm driving and this area right here is not a road because it's not one of these lines on the grid, you don't see a line on the grid right here. That means like I'm going into somebody's house. I might be driving my car in somebody's house to get there. Then I hit the road. Then I go back into somebody's. I might run over mailboxes and knock down trash cans. You know, you just never know. Hit people. Run through houses if you go drive a car this way. Okay. So you can't do that. So the reason they say fly is so that you're not, hurting people or hurting yourself. All right. Walking is a different story, but you would have to walk or drive on the, like not walking because you could walk through, you can't walk through people's houses, but you could at least walk through the yard. But I wouldn't suggest doing that. All right. But if you could walk on the roads, okay, but we don't want to walk. Okay. We don't want to drive. We want to fly. All right. So if you fly, we're talking about that straight line distance again, guys. So from here to here, which means we're looking for the hypotenuse, which is C. All right, let me erase this. I just wanted to explain why they say they're looking for the flying distance. All right. All right, so number 8 says we want to fly from the greenhouse to the stadium. Greenhouse and stadium. So here's greenhouse and there's your stadium. So we want to go here. Fly between these two places. All right. This is my hypotenuse. Keep in mind, it's because it's a slanted side. All right. Somebody saying the hypotenuse. How do you know it's the hypotenuse? I don't even see a right angle. Okay. We're going to draw a right angle. If that's your hypotenuse, we're going to draw a leg coming from this vertex. So we'll call this a leg. Okay. And we're going to draw a leg coming from this vertex to meet this one. So it makes a right triangle. Now all I have to do is calculate this distance. So if I calculate this distance here, I have to go back between. So if I want to calculate this distance right in here, I just count the number of spaces. So that's 1, 2, 3. So that distance is 3 units long. And then if I want to calculate this distance is 1, 2, 3, 4 units long. All right, so what you're going to do is you're going to use the Pythagorean theorem to figure out the hypotenuse. This right here. Okay, so you're going to use the Pythagorean theorem to figure out the hypotenuse. See these two spots, this side and that side make the right angle. See your right angle right in here? There's your right angle. So if they make the right angle, what are they called? What they're called legs. So therefore, they're your A and your B. Now, it doesn't matter. I could have let this 4 units be an A and the 3 units be a B. A and B are interchangeable because a leg is a leg. So it doesn't matter which one is A and which one is B. But this one that's directly across from this right angle will always be C or your hypotenuse. So if you mess up the hypotenuse, you're going to mess up the whole problem. But that has to be C. You can't put an A here or a B there. Okay. A and B are they're your legs. They make the right angle and you can interchange them. This could have been B and this could have been A. Doesn't matter. But you cannot interchange C with anything else. All right. So what we're going to do is on number 8, we're going to write down the Pythagorean theorem. A squared plus B squared equals to C squared. All right. So what is A? Well, according to this, A is 3. So we're going to write 3 squared plus what is B? According to this, B is 4 units long. Again, A and B are legs. So basically, it's just asking you what is one leg and what's the measure of the other leg. All right. What is C? Let me put my line. What is C? Well, we don't know it. Okay, it's our unknown. That's the distance from the greenhouse to the stadium. That's what C represents. We don't know it. There's no number there for it. All right, so all you do is just follow through and square each one. What's 3 squared? Well, 3 squared is 9. Plus, what's 4 squared? 4 squared is 16. Equals 2. Bring down your C squared. We don't know anything about it yet. All right, but I do know that this 9 and 16 represent the areas of the squares on the legs. Okay? These represent the areas of the squares on the legs. And I do know that if I add them together, it's going to give me the area of the square on the hypotenuse. Okay, so that means when I add 9 and 16, I get 25. That means that the area of the square on the hypotenuse is also, it's 25. Now, I don't want the area of the square on the hypotenuse. The area of the square on the hypotenuse, it would be like this. Be whatever this is. So that would be 25 if I were to draw this a square on out right here. Okay, so I don't want that. I want this whole square. I only want this line segment. So what do I do if I only want this line segment right there? Because that line segment is not 25. Again, the area of the square that I would draw on this would be 25. So what do you do to areas of squares to get side lengths? Well, you take the square root. So in the end on these, we'll end up taking the square root. So the square root of 25 and the square root of C squared. Remember, if this is an equation, what you do to one side, you also do to the other. What is the square root of 25? It's 5. What is the square root of C squared? Well, a square root and a square cancel each other out, and you're just left with C. They're inverses of each other. They undo each other. All right, so, and I really don't even put the cancellation part. Okay. So I just say the square root of C squared is simply C. And I don't put the little lines to show that they're canceling out. All right, so C is 5 units, or in this case, they call them blocks. So C is 5 blocks. And C represents the distance from the greenhouse and stadium, between the greenhouse and the stadium. All right, let's take a look at 9. All right, 9, you want to find the distance between the police station and the art museum. All right, so where's my police station? Okay, here's my police station. And here's the art museum. And I want to find that distance. So I could do better drawing it this way. All right, I want to find that distance right there. Okay, so to find that distance, what I want to do is draw a triangle on it. Now, it doesn't matter if you draw your triangle below the segment, below the hypotenuse, or you turn it upside down and draw it above. Okay? As long as you can get from one point, from this point to that point by drawing a right triangle, it doesn't matter whether you draw it above the segment or below the segment. Because I drew this one below, I'm going to draw this one above the line segment, above this line segment, flipped up, upside down, okay? All right, so I'll draw it up here. And I want my right triangle to be vertical and horizontal pieces so they can make a right angle. And I want these two pieces to be vertical and horizontal so they can make a right angle. And there's my right angle right in here. All right, and they make the legs, so I'm just going to count. That's 1, 2, 3, 4. That's 5 blocks, okay? This is 1, 2, 3, 4, 5, 6. That's 6 blocks. Okay, these two are known as A and B. Again, it doesn't matter which one you let be A or B because a leg is a leg. Just as long as you let the one opposite the right triangle be C. All right, so we're going to use the information that we have in the Pythagorean theorem for number 9 to figure out this distance from the police station to the art museum. All right, so we're going to write down the formula: A squared plus B squared equals to C squared. All right, so A is 6. So I'm going to write 6 squared plus B is 5. So that's plus 5 squared equals to C squared. Draw my line and separate the two sides. 6 squared is 36. 6 times 6 is 36. 5 squared is 25 because 5 times 5 is 25. And then I'm going to add these two. 36 plus 25 is 61 equals to C squared. And so I don't want the square, okay, on the side. The square on the side would be whatever I could draw going out like this, okay? I don't want that. I just want just this side length. So since I want this side length, which represents the distance between the police station and the art museum, what do you do with this 61, since 61 represents the area? Well, you take the square root of 61 to get the side length. So that means I'm going to take the square root of C squared, because I don't want C squared. I don't want the square. I just want the side length, which is just C. So the square root of 61 is C. Now, if you wanted to, you could round this off. And we're going to practice rounding now. So take your calculator and find the square root of 61. And you end up with some long decimal. And we're going to round it to the nearest 10th. So this is the decimal that you get. I'm not going to write all these out. But if we round to the nearest 10th, that 1 tells that 8 to stay the same. So we'll say 7.8 blocks approximately is the distance between the police station and the art museum. Put the little squiggly lines. If you wanted to leave it as a square root of 61, I mean, technically it'd be right, but I want you right now to at least round them off to the nearest 10th for me, okay? All right, let's do greenhouse to the hospital. All right, where is the greenhouse? All right, so here we go. Let me erase some of this. I'm going to leave it up here. Do it in different colors so you can understand it. So that's the greenhouse. To the hospital. Trying to get this pen to come up so it wouldn't be so big. Okay, greenhouse to the hospital. All right, but if you notice, the greenhouse to the hospital is a straight line distance. I mean, it's not slanted, it's not tilted. So since it's not tilted and it's just a straight line, you just count the blocks. Well, how many blocks is it? Because you can fly from here to here without making, you don't have to make a right triangle on it because it's vertical. Any vertical or horizontal piece, you just count. So that's 1, 2, 3, 4, just 4 blocks. Now again, if that distance were tilted or like this, you would have to use the Pythagorean theorem for it, okay? Which means you would have to draw a right triangle on it, but you have a vertical piece, so just count 1, 2, 3, 4, because you can fly directly to it, and you don't have to worry about a right triangle. Matter of fact, if you drew a right triangle, this would not represent C. It would represent a leg. So if your distance is vertical or horizontal, it's more like it's a leg itself. Just count it. 1, 2, 3, 4. But if your distance is the hypotenuse, draw a right triangle. on it so you can get the leg. Okay. All right, let's take a look at City Hall and the gas station. All right, where's my City Hall? All right, so City Hall is right here. It's at the origin. I think, let me put 4 blocks here. All right, so let me do this one. There's City Hall and there's the gas station. And what I want you all to do is pause the video and see if you can do it on your own before I do it, okay? And notice that distance is tilted, okay? It's so this is going to be a C. We'll figure out what that equals. All right, and I'm going to draw the triangle not going underneath the segment but above, because if I go underneath the segment, it looks too messy to me. It's in this other one, this triangle right here, and I don't really want that. All right, so I'm going to go above the segment like this. All right, so I'm going above 1, 2, 3, 4, 4 units above, and then to get here, 1, 2, 3, 4. So each one of these distances is 4 blocks. Let me put that in a better color. 4 blocks. All right, this is 4 blocks. So that means A is 4 and B is 4. And C, I don't know, but I'll figure out C in just a little bit. Are we going to figure out C by using the Pythagorean theorem? And that's going to be for 11. A squared plus B squared equals to C squared. And A and B were both 4. So it's going to be 4 squared plus 4 squared equals to C squared. 4 squared is 4 times 4, which is 16. That's another 16. And when I add these together, 16 plus 16 is 32. Remember, these two numbers represent the areas of the squares that I would have drawn on the legs. All right, equals to C squared. But I don't want the square that I would draw on C, so I don't want C squared. C squared represents the square that the area of the square that I would draw on C. I only want the side length. So to find the side length of C, I take the square root. But to make your equation stay balanced, take the square root of both sides. So once I take the square root of 32, I end up with an irrational number. So I'm going to round this off to the nearest tenth. That 5 tells that 6 to go up 1. So this is going to be approximately 5 7/10 blocks. And that's my C. Okay? In other words, that's the distance between City Hall and the gas station. So I'm going to put a squiggly line there. 5 7/10 approximately. All right, and that's how you use the Pythagorean theorem to find the hypotenuse, the length of the hypotenuse. Okay, let's take a look at some more. Let's do number 1 here. It says find the distance of segment KL. So I'm going to draw the segment for KL. All right, there's a segment for KL. And then that's going to represent C. And I'm going to draw the triangle underneath it. Go from dot to dot, okay? All right, so that you can go from this end of the hypotenuse to this end of the hypotenuse. Drawing your right triangle. So this is a unit of 2, and this is a unit of 1, 2, 3, 4, 5. So a squared plus b squared equals to c squared. You can let either one of these be a or b. I'm going to let this one be a, and I'll let that one be b. So I'm going to have 5 squared plus 2 squared equals to c squared. So I have 25 plus 4 equals to c squared, and 25 plus 4 is 29. But I don't want the square that I would draw on the side of the hypotenuse. I want the actual side length. So I'm going to take the square root in the end to get the side length. Square root of 29 equals to c. And I can put this in the calculator. Square root of 29 is, to the nearest tenth, approximately 5 4/10 units. All right, so the segment KL is approximately 5 4/10 units long. Trying to write that for a little better.